Hello my dear students, I am Dr. Anamika Ahirwar, Associate Professor in the Department of Science and Technology at JAYOTI Vidyapeeth Women's University, Jaipur. Now today I am going to take the lecture on the introduction of data science. Now these are the topics which I have covered in this lecture. This first is what is data science, why data science is important, how to do data science, and the life cycle of data science. Now, first start, what is data science? Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data in various forms, both structured and unstructured, similar to data mining. The next is why data science is important. Every company, however, has information, and its business value depends on how much information it thinks. Since late, information science has acquired significance in the light of the fact that it can assist companies with growing business estimation of their accessible knowledge and thus allow them to take the upper hand against their rivals. It can help us know our customers better, it can help us refine our processes, and it can help us make better decisions. Knowledge in the light of information technology has become a vital instrument. Now, how to do data science? A typical data science process looks like which can be modified for specific use cases, like understand the business, collect and explore the data, prepare and process the data, build and validate the models, deploy and monitor the performance. Now come to the life cycle of data science. In this there are 6 phases. First is discovery, second data preparation, third model planning, fourth is model building, fifth operationalize, sixth is communicate results. Now let's explain one by one. In the phase 1, that is discovery, it's important to understand the various categories, requirements, goals and necessary budget before you start the project. You ought to have the courage to ask the right questions. Here you determine whether you have the resources needed for supporting the projects in terms of people, equipments, time and data. You must also frame the business problem in this process and formulate initial hypotheses for testing. Now come to the second phase, that is data preparation. You need analytical sandbox in this process in which you can conduct analytics for the entire duration of the project. Before modeling, you need to search, pre-process and condition data. In addition, you must perform ETLT, extracting, converting, loading and transforming, to bring data into the sandbox. Let's look at the flow of statistics analysis in this figure. First is preparing the analytic sandbox, second performing ETLT, then data conditioning and the survey of visualize. You can R may be used for data cleaning, retrieval and visualization. It will help you identify the outliers and create a relationship between the variables. When the data has been cleaned and packed, it is time to do some exploratory analytics on it. Let's see if you can get this done. Now the third phase is model planning. You can decide the model and strategies for drawing the relationship between variables here. These relationships will set the basis for the algorithms you will be implementing over the next step. Using through statistical formula and visualization tools, you will apply exploratory data analytics, that is EDA. Now look at this figure. In this, common tools for model planning are SQL analysis services, R, and SAS access. R, R has a full range of modeling capabilities and offers a strong setting for interpretive model building. SQL analysis services can use data mining functions and simple predictive models to perform in database analytics. SAS access can be used to access Hadoop data and is used to construct repeatable and reusable flow diagram for model. While there are many tools on the market, but R is the most commonly used tool. Now that you have insights into the essence of your results and you have chosen to use the algorithms, you will apply the algorithm in the next step and you will create a model. Now come to the fourth phase, that is model building. You will be designing data sets for training and testing processes. During this process, you should decide whether your current resources are adequate to run the models or whether you need a more robust environment such as fast and parallel processing to construct the model. You will examine different learning strategies such as grouping, association, and clustering. Model building can be done using the following methods, which is shown in this figure, like SAS Enterprise Miner, Vika, SPCS Modeler, MATLAB, Alpine Miner, and Statistica. Now in the fifth phase, that is operationalize, you provide final reports, presentations, code, and technical documents. During this process, alternatively, a pilot project is often applied in an area of real-time output. It will give you a simple small-scale image of the results and other relevant constraints before you deployment. The last is communicate results. In the communicating results, now it's necessary to determine whether you were able to accomplish your target that you designed in the first step. Therefore, in the last step, you define all the main outcomes, communicate to the stakeholders, and decide if the project's results are a success or a failure based on the step 1 criteria. These all are the 6 steps of the data science life cycle. Thank you for listening and watching. Now we will meet in the next lecture. Till then, goodbye and take care.